complicated function that is based on 2 or more variables, and it's not easy to set up as y equals or x equals an equation. What we can do is we can use what's called implicit differentiation. And so the way that works is we'll do the first derivative with respect to x. And we'll do it term by term. So meaning this term is a product of 6x and y cubed, minus this term is actually a product, x squared y, and this is the constant 7. So using the product rule, which we know from our Calculus 1 skill set, we'll have the first times the derivative of the second, and since that's dy dx, that is a changing differential, and then we'll also have plus y cubed times, well, the derivative of the first is 6 dx dx, but the differential ratio will always be 1, so we don't have to write dx dx, minus the first x squared times dy dx, so we're going with respect to x, plus the y term times 2x equals 0, because the derivative of a constant is 0. Next, what I'll do is I'll subtract these terms, and I'll move them to the right, meaning it'll be negative 2xy minus 6y cubed, and what I'll do is then I'll tidy this up. I'll have 18xy squared minus x squared. While I'm doing that, I might as well left factor the partial, the derivatives, the differentials, excuse me, dy dx. So notice there was a dy dx here and dy dx here. I just moved it to the left. And for a last step, to get the tangent at any point in this function with 2 variables x and y, dy dx will be, this will become a numerator. And we can find the tangent line, the rate of change dy dx, slope, at this equation, negative 2xy minus 6y cubed over 18xy squared minus x squared. This is sufficient. I mean, we could factor out a y and a 2 and get, well, negative 2y times x minus 3y squared, and we could factor out an x and get 18y squared minus x. But if you look, none of these factors really cancel, so we can stop here. And it's usually sufficient when we have a point on the curve we need to analyze. We can just plug in x and y here. It might be a little bit easier with factors. You might be able to see a little more behavior, find some asymptotes. But there it is, using the implicit differentiation with respect to x for this equation, 6xy cubed minus x squared y equals 7.